Okay, there we go. Okay, so I'm gonna be talking a little bit about some of the projects I've been working on this last 9 weeks. Getting back into actual programming and using Python was definitely a lot of fun. I enjoyed it a lot and actually spent quite a bit of time outside of school working on things and just kind of learning using the documentation that Python gives you. Um, Before I start, the dream was just to really learn more about programming. I kind of stopped at the end of last year doing some more IT stuff, like installing operating systems and learning about databases and things like that. But I really honestly missed programming and being able to create things and just having fun, seeing what I can do with it is it's awesome. So some of the projects I made, currently I'm working on Pong. I actually just started it today. The program that took the longest, and these aren't even all the ones you see, aren't even all the programs I wrote. I wrote some smaller ones to get back into it at the beginning of the year. But the one that took the longest was Snake. That game is actually a lot of fun. They give you a little like tutorial on Udemy on how to do it. I honestly followed it for about 10 minutes, maybe, just to kind of get me started. And then after that, I kind of took it upon myself to try to figure it out. And that's what honestly took it so long was the learning process of actually going back and reading documentation and trying to figure it out on my own, which in my opinion, honestly progressed me a whole lot farther in my journey in learning Python. And it actually came out really good. I added a bunch of other little features to it a little bit, not, anything fancy, but, just some fun things to make it kind of mine. Um, I also did dot paint is what I called it. This was earlier in the year. This program actually reads the RGB values of the pixels in an image that is given to using Colorgram, which is its own kind of separate class that someone created. It's actually really cool how it is capable of doing that, and I didn't even have to have knowledge of how it really does that. You just get to use it. I'll show you in a minute. And then after it reads those RGB values, it keeps them in a list and uh, turns them. It creates a painting. It's called a dot painting. I can't remember the artist's name of what he does with those art paintings or like how he like what he envisions when he does it, but it's just a bunch of colorful circles on a page. It's kind of goofy, but it was a fun project. Another one you see is Spirograph. That one's really just a color related, using colors and being able to display the like circled colors on the screen and make the spirograph. That was fun too. And this isn't even all of them. Another one I did was a text-based one, which I don't have on this computer. Was a coffee machine game. That or not really a game. It was like a simulator, if you will. That one was actually quite a bit of fun. You pretty much just emulate how a coffee machine works. In other words, like a Keurig, and it was pretty cool. But I'm gonna go ahead and start with the spirograph. This one's very simple. This one actually took me less than a whole class period. And yeah, let's just see it run. And that's all it does. It spins around, makes a spirograph of a bunch of random colors. Alrighty, and that's finished. Some of the code in this is the random color function. This chooses a random integer between 0 and 255, and that creates your RGB value. So R is like the red, green being G, and blue being B. Those are the different values. If you look, well, I can't show you, but they have the like charts and stuff, and you can choose RGB values on like websites. But yeah, this is a tuple, I'm pretty sure, if I remember correctly. And then you just return the color. This is what sets the screen. It's pretty easy. This is the turtle object. This is what actually does the coloring and the moving around. These are my imports. And this is pretty self-explanatory. I named my turtle Hadley, Hadley moving at the fastest rate. Here's the function to actually get the gap. I actually had to listen to what Angela had to say on this. I honestly don't remember why it was difficult, but I just remember having to look at this because in the beginning, so if I run it again, my circles were like super wide and like took up the entire screen while it did it. And so it had like a bunch of big gaps, which honestly I almost just stopped there. I was like, well, it's my project. It worked enough for me. But I wanted to see what she had to say about it, so I didn't. Okay, and another thing you'll see in all the programs is screen exit on click. So all I had to do is click the screen and it closes. So that one. That one's really simple. The next one I did was the dot one. So here's some of the images. This is what one of the actual, I guess his last name's Hurst. I couldn't remember what it was, but this is what his dot paintings look like. And while doing this project, we got access to DALL-E. So I decided to use a DALL-E generated image in my Python project. And this actually, it goes through and it reads all the pixels, gets their RGB values, and it picks the top. I have it set to 15 colors. So this is actually the colorgram, one of the callings of colorgram. It's called extract, and it's extracting the pixels from this image, which I have over here in my files, and taking the top 15 colors. This is a list that stores the values of the RGB colors. And this is basically all screen setup and getting the turtle set up. This is the for loop on how the turtle actually moves on the screen to paint the dots. It's really simple. Hadley dot, 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 and it just places a dot of one of the random colors. It chooses a random color inside the list that I make, grabbing the values from the image. It's pretty cool. So if we run it, so if you see down here, I actually print the list so I can see it for myself. That was one of the testing parts of it. And you're done. So that's pretty cool. This one was actually one of my favorite ones to do. And now we have the snake game. This game actually took a long time. As you can see, a lot more code, a lot more classes. That's just a text file. Here's food. Anyway, here's the main class. So this is all my importing stuff. Don't even mind these. I was trying to add audio, but I decided I didn't want to. So yeah, this is me creating. Maybe I should show the classes first. So first we have the snake class. This is how the snake is created and how it moves. Here's the function for it actually moving. And one thing you should know is that segments is actually a list, and the list is the different turtles, like cloning of the turtles that we make in the game as you're like eating apples, otherwise known as Mr. Goddard faces in my game, but you'll see that in a second. Let's see. So this is the function to create the snake. Basically just creating a new snake turtle and assigning it its shape, its color, making the pin go up so it doesn't draw all over the place as it's moving. And then you tell it to go to the positions. And then you append to the segments, you get the new snake to append to the segments, which is that list up here. And so it'll follow along the other snake paths. This is for it to move. This is the functions of the arrow keys of actually telling it where to go, and heading. Heading is actually the very original turtle object that is in the front that actually gets it to move, and all the other ones just kind of follow along. But that's the one that actually sets it to move. And it's the heading, and so you set the head to a heading once those are called over here in the main method. As you see, you call the function over in the snake class based on the input key, and it sets the heading to up, and up has these values. Up has a 90-degree value, so it sends it straight up. Down is obviously 270, left is 180, and right is 0 because that's the direction the snake starts. So those values are all based on the starting position of the snake. This is adding the snake. This came later on. Reset was one of the last functions that I personally wrote. So to make it replayable, I made all the snake pieces go to this position, which is not even on the screen. It's actually very far off, 400 pixels on each the x-axis and the y-axis, or more. I don't even know. But then it clears your segments, so you start out with just the original snake piece, and then you create the snake again, and you set the head to segment 0. This is the hit wall function. Basically, it's saying if the original turtle object, which is what we call the head, the x-coordinate of the head is greater than 290, which is the borderline of the actual screen, or the x-coordinate is negative 290, which is the other side, because it's a 600 by 600 screen, or if the y-coordinate is up, all the way, and the y-coordinate down all the way. Then you return true, and you grab that over here if hit wall. So this is the function you call it if snake has hit wall. It's constantly checking. Then you reset the score, reset your snake. You sleep for 2 milliseconds. It shows you the like the game over screen sorta, and then it starts over. Then you update the scoreboard. That's pretty much it for the snake class. Scoreboard, this was the last thing that you actually created because honestly it was just getting the game to work first. These are all the different fonts that I made for the different things. This is actually reading the file, which is this text file over here telling you the high score. Right now it's 21 because I reset it yesterday to try to beat it. I honestly suck at Snake. This is the score class, the scoreboard class. It's a turtle as well. It is actually using inheritance to give it the turtle likeness. Here's the function of updating to the scoreboard. So you clear it, you take the scoreboard turtle to the top left, and you display with this right command the current score, and then also displaying the high score. This is the function to increase the score. This is to reset the score. This one actually, this was the last function I wrote, which is to rewrite the file, the text file, and get your new high score. This is a function to print the game over screen. And this is the function to display the high score. And that's basically it for that. This was really interesting, how to actually get a text file off my computer to be able to keep a variable instead of just wiping everything and there never be a high score. Why not make it more fun and try to beat a high score? And my goal is hopefully to learn about APIs later on in the year, so I can actually have like a Google Sheets or something where you have like a login and password and stuff. And so like me and Jadiel, or me, like anybody in the class, can sit there and use a quote unquote login and be able to keep their high scores, and everybody try to beat each other's high score. Food class was very easy. I wrote this one by myself, completely by myself, and actually made the turtle itself. I looked this up on GitHub on how to actually make an image, like a turtle be an image. And this was it. I had to convert it to a 20 by 20 file, or 20 by 20 pixel image, and turn it into a GIF file. And then you set the shape to that image, and there you go. And what's it called? The rest of this makes it to go to a random spot when the game is started, and then that as well. And then when you relocate, so when it's eaten, when the main file or whatever, when it's constantly detecting if the head is equal to the location of the food, then it calls relocate, and it chooses a new value on the screen to go to. And that's basically it. Here's the image of Mr. Goddard's face that we got in class. So I showed you everything. So let's run it. As you can see, you have your high score in the top right and your current score in the top left. High score is equal to 21, which is what it was in the file. Let's see if we can beat it. Hopefully I don't suck on video. Oh, we beat it. Okay, let's die. And as you can see, it tells you, and then if you look, the top right, it's been updated and it plays again. The actual key to get the game to stop is G. I had to do that to make it replayable. So if I press G, once I've died, it will print your game over, your high score, the current high score. And it says down here, thank you for playing Snake. And that's pretty much it. This is what I've worked on. The hurdles and the challenges I faced was honestly, I would say the hardest challenge was just programming Snake in general, trying to learn as much as I can because, I mean, honestly, it was a lot of programming. It took me about 2 weeks to write it, 2 hours a day ish. The future, from here, I just want to keep on learning as much as I possibly can about Python and just create a bunch of more fun projects. I want to do a lot of data sorting stuff using Python to actually have real world applications instead of games that have already been created, because if you know, Python really doesn't make games. It's more for, data sorting, gathering data, stuff of that nature that's quite interesting to me. But that's basically it. Thanks for watching.